Rankine Simulation and Solar Desalination Systems. www.redslibrary.com.
Hi everybody. First I want to share with you. Today we are our intention is to talk about geothermal binary for organic Rankine cycle, multi effect distillation, parallel feed configuration. Actually, we demonstrated this before, but my intention today is to not to demonstrate how to model or to open your model, but is to how to extract your data and how to deal with your analysis and all stuff like this. First, you have to go to your destination folder. Suppose this is my destination folder here. As you can see, I put my all my models here in one folder, so I can easily go here and from this side, and I can easily select geothermal binary organic Rankine cycle. Okay, we have two versions. I updated this old version, so I am going to deal with version 2. Okay, version 2, it's I make a tiny reformation related to in version 1. Actually, you have to assign the well temperature, geothermal well temperature, but in the second one it has to be calculated. Now let's go and see. This is our model. As you can see here, this is our model. You have to check this. If you didn't check this, you will find your or you have to go to here, view model browser. Yes, model browser. If you uncheck, it will appear like this. So I prefer to do this. Model browser, show model browser, and check all of these things. Okay, everything is quite calm and easy. Anyway, let's set our this is our simulation time. I have to set at 0 just for beginning. Okay, this is our model. It contains it includes a geothermal well, pumping unit. This pumping unit is responsible for geothermal pumping. Evaporator, boiler heat exchanger as an intermediate unit between toluene and water steam from geothermal. A turbine unit operated for toluene. This is our organic working fluid is toluene, because its behavior looks like water, so it's quite interesting, most efficient than pentane or other working fluid, but we can add more working fluids. A recuperator unit, because this is a positive slope. Toluene has positive slope on TS diagram, therefore we can add recuperator unit. An MED, as you can see here, MED parallel feed configuration. This is brine pump. This is, I think, yes, this is brine pump, distillate pump, and this is a feed pump. Okay, and this is a thermoeconomic and exergo-economic block. This block is quite interesting about if you are going to deal with exergetic analysis and cost parameters and so on. Thermoeconomic, actually. This is end condenser unit, and we have first pump of the cycle. This is organic Rankine cycle pump, and this is cost blocks and performance if we are going to deal with or to recognize our outputs, such as specific bulk consumption, gear ratio, total average stability, and so on. And this is our cycle. You have to check this in order to emphasize. Okay, our cycle is, as you can see here, geothermal, boiler heat exchanger, and pump. This is steam cycle through the intermediate unit. And we have here, this is organic Rankine cycle. As you can see, turbine unit, recuperator, organic pump, and evaporator as an intermediate. And this is MED block. Okay, So we this MED is the stream outlet from the recuperator, as you can see here. This is outlet stream from I'm sorry, I have to use this one. Yes. Okay. I'm sorry. Okay. Okay, the stream outlet from the turbine unit will go to the recuperator unit. Then the exhaust stream is responsible for the first effect in MED as a steam generator for the MED, and the condensed steam is repumped again and responsible for preheating the stream, the L stream to the boiler heat exchanger in order to increase the efficiency of the boiler heat exchanger and so on, and saving much thermal power. Okay, let's go. Before we go, you have to double clicking here, and you can let's make some emphasizing here. Okay, you have to assign some things. This design, it's responsible for productivity. Suppose I need to assign 2000 meter cube per day as a productivity, and we can increase this. And we can go through operating conditions such as ambient temperature and inlet turbine unit temperature. Suppose I need 168, 200, it's up to me. This is outlet temperature should be up greater than lower than well temperature, because well temperature is the main source of steam. And we have condensed steam. Suppose I need to extract my steam at 60, you can enter here 60 degrees Celsius. This is from the first effect of MED. Okay, we have to assign some inputs. You can go through that. This is geothermal well, steam pipe diameter. Just we can assign only this parameter. Okay, what we are going to discover? Okay, we're going to discover the following. This is geothermal well, as you can see here. Just clicking here, clicking on geothermal well. This is a block diagram of geothermal well. This is inputs and outputs. If you have any intention to reform something or to add or to remove, or you have to double click on this block. This is the edit block. It's fully editable. You can reform here. You can add more outputs. This is outputs in between these matrix brackets, as you can see here, and this is your function name, and this is your inputs. Suppose I need to input something. Suppose I'm going to input here. Suppose I'm going to write any name here or any something, but you have to use this here. Okay, this is input. If you click yes, let's go saving. Let's go for the, as you can see, it adds some stream. It's ready for input stream, as you can see here. So we can add something here. Suppose it's a constant block. Suppose I need to add input data or another parameter or something like this. You can attach it here, okay, and you can easily enter your value, whatever. You can deal with this parameter as an input, okay, but it should be has some influence, some kind of any influence on the block, okay. It's not just an input and so on. Okay, we can reform this again. I have to remove this. Okay, these are our inputs parameters that we have to use here or to deal with. Okay, everything returned to its original case. Anyway, okay, based on these inputs, we have to discover these outputs. Exergy structure rate, as you can see here. I'm sorry. You can okay. This is exergy destruction rate, exergy of water inlet, water outlet. Okay, that's so important. Enthalpy inlet to the well. Okay. Okay, this is well depth in kilometer. Okay, this is well depth parameter. You have to discover this one, and this well depth in feet, because based on this feet you can calculate digging pipe hole diameter, digging pipe casing diameter, geothermal well pressure, well head pressure, and some pressure losses. You can assign, you can discover these outputs by clicking on this or double clicking on the stream. You can write the name. Suppose I am going to enter this. Okay, copy. Okay, I coming here and double clicking and write here the name of the stream. Okay, but you can remove streaming signal, because, or add streaming. I'm going to add this streaming signal because my intention is to discover the effect of, or to address such as the effect on this parameter. This is inch. Anyway, okay, these are outlets based on ambient temperature, inlet well temperature. This is inlet well stream temperature. This one, the stage after boiler heat exchanger unit. This inlet well temperature, and this is enthalpy of this stream, enthalpy, and this is well temperature, top steam well temperature. We have to discover this one. I write T well temperature, T well, adding some okay, T well temperature, because I need to know what is the temperature of the well based on our calculation. And this is mass flow rate, well mass flow rate, as you can see here. This is one mass flow rate. This is output. We need to discover this one also. Let's go and discover. I am well kilogram per seconds. This mass flow rate. Okay, now everything is ready for geothermal well. Okay, for this pumping, this is geothermal pumping well. Okay, you can assign just efficiency of the pump. I think 0.75 is quite interesting. So you can go through and you can reform the model based on what you would like. Okay, this is for water stream. Okay, pumping power. We have to discover the pumping power. You can attach this away. Okay, and we can write here geothermal, and we can double clicking and select stream signals. Okay, we need to know this. We need to know how much of pumping power based on our adjustable things. Anyway, okay, this is pumping power based on pressure difference. As you can see, we have pressure losses through pipes, pressure loss to the system, and top high pressure. Okay, and well temperature also is responsible for, because we need well temperature because it's responsible for raw density. Okay, for evaporator is a little bit complicated because we have here 4 streams: inlet from inlet tolling stream, outlet tolling stream to the turbine, as you can see here, inlet and outlet organic streams, and inlet, which is boiler heat exchange, inlet vapor stream, and outlet water stream condense it, bump it again. This bump, I'm sorry, this is what, this is not a steam, this is a liquid streams, but this endless steam stream from geothermal well, and this outlet from the geothermal well. So it's a little bit complicated. You can edit everything here. We have turbine here, and we have turbine side and water stream. I'm sorry, this is water stream side for the well. Okay, it's complicated. We can calculate many parameters, such as top well temperature. This temperature we are going to calculate. It will be calculated from this intermediate unit based on this stream, and this stream is also calculated. Any stream is, we have 3 streams calculated, and 1 stream is we assigned this one. We only assigned the top turbine inlet or top vapor stream. This is the only one we already assigned from the beginning, from here, as you can see here. Okay, this one, inlet turbine temperature. Okay, so we have to discover temperature, enthalpies, vapor enthalpy, entropy, what is the area of polyheat exchanger, number of tubes, pressure losses through the tubes. It's some kind of heat exchanger, so it's a little bit complicated. Anyway, for turbine unit, quite easy, because with such configuration we need to discover how much power we are going to gain from this process. Okay, and we have to calculate the outlet temperature from the turbine unit before going to the recuperator unit. From recuperator unit, it's some kind of also heat exchanger, because we have 4 streams, as you can see here. Inlet, this is turbine stream hot side, and this cold side, which is going to be preheated before going to the boiler heat exchanger. It's some kind of little bit complicated cycle. Anyway, this recuperator. What is important here is this size. T recuperator outlet temperature before going to the first effect of MED. So I need to discover this. I will assign here T recuperator out, degree Celsius. It's quite interesting. And this one is T pump recuperator out. This stream is going to the pumping unit. It's quite interesting too. I have to discover this one. T pump recuperator out, degree Celsius. It's quite interesting. These 2 streams, of course, we have energy, we have area, exergetic analysis, and so on. But for thermoeconomic analysis, we have to discover streams, temperature stream, the temperature of each stream. Anyway, okay. So, and for multi-effect distillation. Multi-effect distillation, as you can see here, this is steam temperature, inlet steam. This steam is coming from the recuperator unit, and we can discover also many parameters, such as total steam mass flow rate. This steam mass flow rate is here. I'm sorry. Yes, this is steam mass flow rate through the organic Rankine cycle, and by this one we are going to calculate the water in water geothermal water stream mass flow rate, also total stream, total mass flow rate. And for this one we can discover also area profile, geothermal vapor profile, effect by effect, and we have turbine bumping for turbine organic Rankine cycle and cost analysis. Okay, Let's go for MED, and sure, we can assign here effectiveness for the boiler heat exchanger unit. It's quite interesting. This parameter is so important because it will affect on the top geothermal temperature and the depth of the geothermal well. Lower effectiveness of boiler heat exchanger means you have to dig more and more in order to extract your steam. Therefore, okay, this is a turbine unit. We have to assume just the efficiencies of turbine and generator. For MED, this is quite interesting here. Okay, we have to assign seawater temperature or input saline water temperature, seawater salinities, and blow down salinities, because it's a design unit. Brine blow down, this is brine blow down here, as you can see here. This is brine blow down, this is B, black one, black stream. We have to assign brine blow down temperature and some efficiencies, and design how many number of effects you are going to use. 2, 4, 3, 10, 12, it's up to you, because if you are going to assign more effects, it will increase your efficiency or performance of the cycle. So you have to it will cost you low mass flow rate. Okay, let's go for, suppose it's 6 effects. That's quite normal, usually used 6 effects. Okay, again, let's, okay, we need okay, suppose we need 10,000, or make it 2,000 up to 10,000. Let's go and hit run and setting our time for infinity. Okay, let's hit run and see the effect on this, for example, geothermal well or turbine pressure. Let's go and see. Okay, here's our geothermal well, as you can see here. I'm sorry, I have to. Okay, after this is our geothermal well, we have to keep watching. Suppose I'm going to change the top steam temperature for organic Rankine cycle. As you can see here, it's increasing inlet temperature or to the turbine unit would increase the well temperature, as you can see here, increasing, and at the same time would increase the well depth, as you can see here, increasing the well depth, increasing, and the same effect. Suppose I'm going for increasing or changing the steam condensate. Okay, changing the mass flow rate by the way. Okay, increasing the total productivity of the plant would increase the total mass flow rate through the geothermal well and show the power. Okay, suppose I am going for, let's go for turbine unit, going for the turbine unit. This is the power. Okay, increasing the productivity, mass flow rate, I'm sorry, productivity would increase the power generation by the turbine unit, and you can realize this power consumption by the turbine unit. Suppose you're increasing here, increasing effect on the power, the pumping power, and so on. That's it. Stop. As you can see, let's go and discover some figures. Anyway, okay, sure, you can control, I'm sorry, if you would like to control to address the effect of brine blow down or ambient temperature or number of effects, you can it's quite easy. Let's go for the data inspector. These things, okay, this is total, because we changed the productivity. There is some kind of a change in total feed flow rate. More productivity needs, at this point I try to lower the productivity and increasing it again, and this effect on the end condenser and total this total productivity, and this feed flow rate, and this steam mass flow rate, the same behavior. This performance ratio, because 6 effects. This is steam temperature. This fluctuating in steam temperature, and this area of the evaporator unit. This is with well depths. Just mass flow rate through the well. This is mass flow rate through the well, and yes, this is well depths. Okay, increasing the productivity would increase the well depth. Decreasing the productivity would decrease the well depth, and so on. Sure, as a power from the turbine unit, if you need more power, you have to dig more, and so on. And this is the power from the turbine unit, and this is pumping power. This is pumping power, geothermal pumping power. Okay, and suppose okay, if I go here for the turbine unit, yes, this is the net power. Let's go and discover net power. I forget net power. Yes, this is net power. Net power versus the total power. Sure, you can stop this and save this, and you can make another run by changing another parameters, and you can put same curve, curves on the same figure. You can 2 figures, 3 figures, and so on. Suppose I'm going for one point run. I'm going for 10,000. I'm sorry, 200 inlet temperature to the turbine unit, and 65 condensed steam through the first effect, and okay, 6 effects. Brine blow down, suppose it's 35. Okay, it's quite good. CO2 salinities, 6 effects. Efficiency is okay, and let's go and hit run. Okay, for this geothermal well, I'm sorry, geothermal well, this is our depth, 0.9, almost 1 kilometer depth. Some piping hole diameter in inch, and we have here this top well temperature 228, total mass flow rates, and for turbine unit we are going to harvest net power by 15 gigawatts, almost 15 gigawatts as a net power. Okay, this is the total power, and this is the net power. Outlet turbine temperature is 100. From Evaporator, as you can see here, is 73. This is steam temperature for the first effect, and this is the preheated steam through the Evaporator, is 88 degrees Celsius. And this is multi effect. Let's go for multi effect. You can discover total steam flow rate, distill profile, brine profile, salinity profile, brine blow down profile, effect by effect. This is the first effect, second, third, fourth, 6 effects. Area profile, as you can see here, this is area profile. Total length by each effect, and this is power for each pump. This power for each pump, and you can go here and you can draw some figures if you would like. This is salinity profile. You can draw, this is salinity profile, and you can for this is our distill profile, and sure, this area profile for MED, effect by effects, 6 effects. Okay, you can draw a number of effects. Let's go and select number of effects. I think it is not here. Anyway, we can go for MED, and we can select this one. Okay, for MED, yes, MED parallel feed, and we can choose number of effect parameters. Let's go and seek it. Yes, number of views. Yes, this number of effect, and we can save final value to workspace, and we can hit run again. Let's hit run, because I would like to do a relation between number of effect and number of effects and brain profile. Suppose it's brain profile, and let's plot. Okay, this number of effects, and this is brain profile, and as you can see here. So it's quite easy for you to extract your data by many ways. You can even this signal inspector curves. You can copy or plots, or create a report, or send it to a figure, or you can export this data. You can export this. You can assign this curve and export it, so you can find yourself dealing with a matrix of data. As you can see here, this is a matrix, this area file. So you can copy this and deal with it, or save it to Excel sheet, or something like this, and you can send to figure. You can send this to figure. It will take a little bit time. Okay, send all the subplots to Matlab figure window, as you can see here. It's trying. Yes. Let's go for tools, figure tools. Okay, and you can discover all plots and control these based on your need. Okay, this is feed, area, condenser, total product, and you can control and increase and control whatever. I mean, dealing with your figure based on your analysis, or your report or sheet you are going to introduce. Finally, I would like to thank you. I hope that such video is being helpful to you, and I'm looking forward for your support. Like, share, subscribe. Thank you very much. First, Muhammad Shah with you, Library.com. Thank you.